All right, so thieving things from my office aside, let's do this one. So number 42 wants us to calculate a bunch of stuff with f of x is, big and little f's again, right? So I have a capital F that's e to the minus x squared, and a little f that's minus 2x times e to the minus x squared. You might notice that the e to the minus x squared stayed there.
Yeah.
That's something that you might file away in the back of your head. And g of x, that's that thing we learned yesterday, right? Mm-hmm. There's some kind of a rule from going from capitals to lowercase where you take the power down and then do one lower power.
Is that similar for the F's?
Yeah, that's actually kind of a rule here. The rule here is a little more complicated.
Okay, because I vaguely remember that, but it's been 2 years since I've
done
that. So.
Don't get attached to that rule for anything other than x to powers.
Okay.
This one is not an x to the power, so it doesn't follow that. Like, it's not an x to a number, so it doesn't follow that rule.
Right.
Its rule is a little more complicated.
Okay.
And then I have here h, which is f over g, and, capital H, which is f over g, and little h, which is little f times big G minus big F times little g over big G squared, which is some kind of a fraction-y thing. And this is a rule for how you get from this one to that one. Okay, so what do? They wanted me to find capital H and little h. So, yeah, so just take stuff and plug it in. So capital H should be really easy. Capital H should be
e to the negative x squared.
E to the minus x squared over
x to the fourth.
X to the fourth. Okay, so that's the function that we're going to be differentiating using this rule that they gave us. And little h is, what's up?
Can you take the e to the x squared and throw it in the bottom, or is that not how it works?
Sure.
Okay.
Yeah, you could apply some exponent rules to this thing. Like, for instance, you know that this negative in the exponent means that I could write that thing in the bottom. So you could also rewrite this as 1 over e to the x squared times x to the fourth. That would also be fine.
Can we just take off the log of it, though?
Don't do that. So you're not trying to solve, right?
Yeah.
So don't apply inverse functions. You're just trying to put this in. So
And then, so technically we could,
that's the capital H.
if we were just given capital H, we could get little h without the rest of that stuff in calc.
Yep.
Okay.
Yeah, you'll memorize this rule for going from this thing to that thing. I won't phrase it quite that way, and I don't think Meryl will either, but this is close. This is the right rule at least.
Okay.
So, how do we get little h? Yeah, just take the stuff and plug it in, right?
Yeah.
So you plug little f, so we got minus 2x e to the minus x squared. And then what else do we need here?
Times x to the fourth.
A capital G, right? An x to the fourth. And then we need a minus, capital F is e to the minus x squared. And little g is what? 4x cubed. And then this is all over
X to the fourth squared. So x to the sixth.
x to the fourth squared. Okay, and now we have to
So it's
simplify because you said that. Damn it, Joe.
Sorry.
So what's x to the fourth squared?
X to the 8.
X to the 8,
Oh yeah.
right? Because it's x to the
Yeah.
fourth times x to the fourth. So all told, there's 8 x's multiplied there. And then up top here, I guess we should do some simplifying. What do we got up
You
top?
can pull out a 2x e to the negative x squared.
Don't factor anything out.
Why?
Okay, fine, we'll factor
No.
something out. What do you want to factor out? A minus 2x cubed e to the minus x squared. You guys see that's what's in common in everything there? Right? There's a minus sign, there's a 2 and a 4, so 2's the common thing. There's 5 x's here and 3 here, so I can get 3 out at most. And then there's a that thing, which I can get out of both.
Do we have to do that?
No. Ethan wanted to.
Just
How do you
making
get
sure.
So what are you left with here?
How do you get 5x's?
Because you have an X between the
There's
two.
an x, and then times something, and then times x to the fourth, right?
Aren't those different exponents though? I thought you could.
Yeah.
Maybe x to the 1. and
X to the 1 times x to the
Well,
fourth, you add the
Oh,
exponents.
okay. Alright.
So all told here, what am I left with? Good. X squared. You guys see that? And I accounted for everything else there. And then in this guy, what am I left with?
I have two, not five.
So I'm left with a 2, and I'm adding or subtracting the 2? No.
Adding.
Adding. You guys want to see that?
Yeah.
Okay, so
Because just the e to the negative x squared is 4x cubed.
so this would be your answer, right? You could just be done there. Let me show you in detail how I did that factoring. So I looked at this thing, right? And I thought, okay, there's a -1 times a 2 times x times x times x times x times x times e to the minus x squared. You guys see that?
Switch things when you multiply.
Like that's everything that's in this piece.
It's the associative property.
Yeah, you're allowed to multiply in any order.
Oh,
Right?
yeah.
That's why you just put that.
So I just put the numbers out front, and then I put all my x's, and then I put this other freaking giant thing that I don't know what it is. And then here, right,
Okay, I see what
in all this stuff, there's a minus, really I'm thinking of adding this, right? And then there's a -1 times a, I guess I should think of 4 as 2 times 2.
Yeah.
And then there's 3 x's, and then this e to the minus x squared thing.
Okay.
And so I'm looking for what's in common, right? So the common stuff is there's a -1 in both pieces, there's a 2 in both pieces, there's 3 x's in both pieces, and there's this guy in both pieces. So that's what I factored out. I got a minus, a 2, 3 x's, and a back thing, e to the minus x squared.
Yeah.
And then what am I left with?
X squared.
I'm left with 2 x's, a plus, and a 2. So I got x squared plus 2.
Makes sense.
Cool?
Yeah.
You might want to do, like, this factoring thing might be a good idea if you were going to, like, set this equal to 0 and try to solve.
Yeah.
Right? Because then you could apply the zero product rule to it or something. Cool? Other things?
I kept doing stuff to it.
Yeah, stop as soon as available. This is good advice for you guys because you're
Well, it said
You're
to
good at
simplify,
doing-
So I kept trying.
yeah, I don't care how much you guys simplify. So I care that you can simplify.
Yeah. You
So
should just-
try not to demonstrate to me that you can't simplify. Right? Because if you don't, then I'll just assume that you know how, and we can both be happy about that. And if you prove to me that you don't know how to do it, then I have to take a point off, and it gets to be this like soul-crushing experience for me and for you, and yeah. So just stop. Oh, and when you do it, don't screw it up.